We are technically right now in an ice age. If you live in upstate New York, that may not surprise you. It may seem that way half the year anyway. But for the past 2.5 million years, global climate has been oscillating between stages with major glaciers covering parts of North America and Asia, and basically flowing from more northerly latitudes to the south. This area where we're sitting right now used to be covered by a mile-thick glacier, and then retreating back again, or melting back, and then advancing and retreating and advancing and retreating over and over again. That's actually happened about 50 times in the past 2.5 million years. The glacial interval is the one in which, of course, we're actually covered by one of these continental ice sheets. The interglacial is a fancy name for the intervals in between, when and basically is the climate right now. Without thinking about, if it weren't for present human-mediated climate change, we would be expecting to re-enter a glaciation over the next several tens of thousands of years. Upwelling zones are parts of the ocean where water flows from deeper in the ocean up to the surface. And this occurs in places where surface winds essentially either pull water away from the coast. Now imagine if you pulled water away from the coast, something has to fill in where there would otherwise be a hole. Of course, there's never actually a hole there, because as water is pulled away from the coast, water from deeper in the ocean fills in the space. This also occurs along the equator, actually, and some other parts of the world ocean, but most upwelling occurs either along the equator or along coastlines. And when water comes up from deep, it carries with it nutrients that are from organisms that have, and their and other detritus that has sunk to the bottom, has degraded, rotted away, basically. Remineralized is the technical word. And so you get nitrogen and phosphorus and other nutrients that are necessary for algae to grow, being carried up to the surface by these currents. And when the nutrients get up to the surface, often the algae bloom. There's suddenly a great deal of this algae. And this, of course, causes fish to thrive and so on, and many of the world's biggest fisheries are in these upwelling areas. Our museum serves communities at a number of different geographic scales. It's true that our primary audience, that is visitors who actually come physically to the museum, are in either the Ithaca community or within perhaps an hour's drive, 45 minutes drive away, and we get a certain number of people who come as tourists to the state parks in the summer. Sometimes they come from further afield. But we see our educational outreach mission as much bigger than the local community, but we have to reach those other audiences in different ways. So, for example, we produce exhibits that go to other places. So if we can't get to, if people don't come to us, we can go to them with the physical stuff. We also, like so many places, have a website where you can get additional information. We produce printed publications. We work with teachers and students across the country. So again, it really depends on the context. It may be that somebody in a county in some other part of the state, or maybe even some other state, may see Ithaca, New York as being irrelevant, but the science education issues may well be very relevant in their own community, And our goal would be to go to that community and talk about how those issues relate to their specific situation and draw that connection. A good scientist is curious about the world. I think scientists come in lots of different forms, different sorts of talents are used in the various kinds of scientific processes that we use to figure out how the world works. And so some people who are good scientists ask really good questions about how the world works and figure out clever ways to figure out what the answers are, taking away other variables and simplifying the problem to the point that they can figure out what's really at work. There are other people who are scientists who are really sort of explorers. They understand the significance of a good question, but their role in science might be to help make new discoveries, find new kinds of data that are appropriate to the problem. A handful of scientists do all of those things well, but in fact the scientific community works best when there are a whole bunch of different people with different ways of thinking all contributing to science, and at the heart of science is coming up with ideas that can be tested with real data. And so being a scientist requires really appreciating that at a deep level. It's not just about going out and looking at something and describing it. It's about making an argument for or against a particular hypothesis based on making real observations. Science is a method of understanding how the universe works through asking and answering questions using real data, using real observations. And the bottom line is that it's driven by ideas that get tested through these observations and then building upon that.